Here's a simple question for you. When you picture the solar system, what comes to mind? The sun in the middle, planets circling around it in a flat line. That's the picture every textbook gives us. But what's above that flat picture? What's below it? Nobody ever asks that question. And hidden inside it is one of the most surprising truths in astronomy. Over the next 6 minutes, we're going to leave the solar system behind, travel up, travel down, and finally understand how up and down actually work in space. Stick around till the end. The picture in your head is about to change completely. Let's start with a basic question. Why do all the planets orbit on roughly the same flat plane? Couldn't they just go in random directions? To answer that, we have to go back 4.6 billion years. The solar system started out as a massive cloud of gas and dust, a nebula that began collapsing under its own gravity. Think about spinning a ball of pizza dough in the air. The faster it spins, the flatter it gets. That's almost exactly what happened here. As the cloud spun faster and faster, gravity and rotation flattened it into a spinning disk. Most of the material piles up in the center and became the sun. The leftover dust and gas still spread out across that flat disk slowly cooled, clumped together, and became the planets. That's why, even today, every planet from Mercury to Neptune orbits the sun in almost the same flat plane, all moving in the same direction. This imaginary flat sheet even has a name, the ecliptic plane. Think of it as the ground floor of our solar system map. Now here's where a natural question pops up. If the planets are all on this flat plane, is there really nothing above it or below it? The answer is, there's plenty there, just not what you'd expect. Even though the planets sit flat, the solar system itself is not flat. That's because not everything in it was born on that same plane. First example, the Oort Cloud. Instead of being a flat ring, it surrounds our entire solar system like a giant hollow sphere, above, below, and on every side. It stretches from roughly 2,000 astronomical units out to 100,000 astronomical units. 1 astronomical unit is the distance from the sun to Earth. This is where long-period comets come from. Because they're not confined to the flat plane, these comets can dive into the solar system from any angle, straight from above, straight from below, anywhere. That's exactly why some comets seem to appear out of nowhere at strange, steep angles. They were never living on the flat plane to begin with. Next, dwarf planets and Kuiper belt objects. Pluto is the textbook example. Pluto's orbit is tilted about 17 degrees away from the ecliptic plane, so Pluto is constantly drifting slightly above and slightly below the flat line. But all of this is still happening on a fairly local scale. To really answer what's above, what's below, we need to zoom all the way out. To the level of the entire Milky Way. Here's where things get genuinely mind-bending. Our solar system's flat plane, the ecliptic, does not line up with the Milky Way's flat plane. Compared to the galaxy's main disk, our solar system is tilted by roughly 60 degrees. What does that actually mean? Up, from the solar system's point of view, is one direction, but up from the Milky Way's point of view is a completely different direction. When we move up relative to our own solar system, we're only moving slightly upward relative to the galaxy, not straight up at all. Picture it like this. Imagine a large dinner plate resting on a table. That's the Milky Way's disk. Now imagine a coin placed on top of that plate, but tilted at an angle. That's our solar system. The coin's up and the plate's up simply don't match. Why does this tilt matter? It means our solar system isn't sitting in some neutral, stable spot inside the Milky Way. We're tilted and orbiting at an angle. This is, honestly, the most underrated fact in this entire video. As the sun orbits the center of the Milky Way, it doesn't just glide along flat. The sun actually rises and falls through the galactic plane, bobbing up and down like a ball bouncing gently on a spring. This oscillation takes about 30 million years to complete one full up and down cycle. Right now, we happen to be sitting fairly close to the galactic plane. Why should you care? Closer to the galactic plane, we pass through denser dust clouds, busier star-forming regions, and stronger gravitational disturbances. Some scientists have proposed that as the sun crosses the galactic plane, it could disturb comets in the Oort Cloud, sending them tumbling toward Earth. Let's zoom out again, this time to the scale of the entire Milky Way. Above and below the visible disk, there's a region called the galactic halo. What's hiding up there? Globular clusters, dense balls of thousands, sometimes millions of old stars. The Milky Way has well over 150 of them. But the real twist is the dark matter halo. The Milky Way's visible disk is 100,000 light-years across, but the dark matter halo stretches far beyond that. possibly 600,000 light-years or more. This invisible material wraps around the entire galaxy like a massive hidden sphere. Think of it like a glowing light bulb sitting inside a massive, almost invisible glass globe. You can see the bulb, but the globe is nearly impossible to spot. Let's zoom out even further. The Milky Way isn't alone, it belongs to a larger family called the Local Group, Milky Way, Andromeda, and over 80 others. Now, what's above and below at this scale? On one side sits Andromeda, but on another, there's the Local Void, a massive, almost empty region. Zoom out even more, and there's the Great Attractor, a massive region pulling our entire local group toward it at 600 kilometers per second. One last level to go. The entire universe is woven into the cosmic web, long filaments of galaxy clusters strung together like threads. Picture a kitchen sponge. The solid parts are like the filaments packed with galaxies. The holes are the voids, vast regions with almost nothing. That's what the universe looks like. Our Milky Way, our local group, we're just a single point sitting somewhere along one filament. So what's the final answer? At the largest scale, there's no absolute up or down, but at every level we walked through, there's a different version of it. The solar system is flat, but wrapped in a sphere. It's tilted 60 degrees from the galaxy. The sun rises and falls. The Milky Way has a dark matter halo. Next time someone tells you there's no up or down in space, tell them, at every larger scale, there's a completely different one waiting to be discovered. If hidden systems like this are why you're here, hit like and subscribe. There's another invisible system waiting to be unlocked in the next video. See you there.